Can anyone confirm whether my screen is visible?
Yes, we can see your screen, sir.
Yeah, okay, good. So, so it's a ETAP demo software. So once you open the ETAP demo software, you will come to this page. So I will tell you how we can work in this software and what are the capabilities this software has, etc. So the first one is the pencil symbol. It is the edit case. So in the edit case, we can able to add, that is addition and deletion of any components we can able to do, then making the new single line diagram or connecting two buses, etc. We can only can able to do in this edit bar. So, and after that, we are having multiple options for the analysis. The PQ is our load flow analysis. This one is short circuit analysis. Everyone, please follow my cursor. This one for arc flash analysis. The next one is motor starting analysis. Then this one is harmonic analysis, and this one is transient stability analysis, and this one is protection star and coordination, that is relay coordination, and this one is star protection and coordination. So this plus or minus P is DC load flow, DC short circuit, then DC arc flash. So these are all the studies option what we have. So still we have some other options also. So mostly we will use these are all the studies. So primarily load flow analysis is our basic one. Then after that we are having short circuit, and after that harmonic analysis. So in this training session we are going to see these three analysis only. So other than that, uh, we are not going to cover in this session. So about the software introduction, in this right hand side, you can able to see the power system components. The first vertical is the AC component. In the second vertical up to this dotted line, this will be the instrumentation component. In the second vertical, in the bottom one is DC components. So based on the analysis, we have to pick and paste the component inside this working sheet, and we can do the analysis. Other than that, for opening the new project, so this project I open the example which is available in the ETAP. Suppose if you want to make the new projects means we can click from here. This press symbol is the new document. So from that you can able to work on this new project. So starting from this power grid to the till the load, remote end load, you can able to make the new design. Then second one is the edit option. Some cut copy paste option is available here. Then third one is the view option. Some task bars, status bars, etc. will be available in this option. Then fourth one is the project. So in project, normally we have to give some introduction about the project setting. So before starting any project, so we have to do this project setting. The first one is the information. So in the information, what is the project title, what is the location, who is the contract, and who is the engineer who is doing the activity, and which company he belongs to, and if any remarks is there. So this is some basic information about the project. So this is an optional one, whether you can include it and if you don't want, then you no need to include. Then second one is the standard. So this one is a very important one. So generally we know no. So the people in Europe will use IEC standard, and people in American countries will use ANSI standard. So this software has two options. One is IEC and second one is ANSI. So based on the country where your project is, accordingly you have to select which standard you have to follow. So I am in India. Here mostly we are following IEC standard and our frequency is 50 hertz. Uh, so here in the next one is a frequency option. So this one you have to select what frequency, base frequency you want to consider, whether it is 50 hertz frequency or 60 hertz frequency. That frequency range you have to select, and the third one is the unit system. So the English option will be used uh, for ANSI, and one more option, that is metric. Metric unit system will be used for IEC standard. Then the first three is mandatory, and the next one is optional. So how you want the date format, whether it is month, date or year, or date month year, or year date month. So here we are having multiple options. So normally in India we will follow uh, date month year. So this one you have to select, this is optional one. The next one is currency. So how your company is going to bill the particular company, whether it is in dollar or something like that. So this one also optional. So the first three setting is important for all the power system modeling in this software. Then next one is setting. So this setting we will talk later. Then next one is option. So in that option, some saving options are there. The first one is the auto save. Second one is the prompt before saving the project. So suppose if you are doing the project, adding the components continuously or changing the things and doing the studies. So sometimes you forgot to press the save option. So if you are not saving that, then the modification what you have done recently, it will not save. So in order to avoid that, by enabling the auto save option or prompt before saving the project will help you. So normally if you give auto save, then it will ask in how much frequency I need to save. So here the default is 30 minutes. So it is user defined. So you can able to modify this one according to your requirement. Either it is in 1 minute or 5 minutes or 30 minutes. So like that. Then about the components, I will go to one by one component. The first one will be our bus. Okay. So, for about the capabilities of the ETAP, so this is the demo version, and this demo version having the capability of maximum 12 buses. So those things you can able to find it, the capabilities of the software you can able to find it through this help option. Then about the ETAB license. So here you can able to see the capabilities. So it is a demo version. So it has total days of 30, then remaining days of 30. Then about the features available in this demo version, you can able to find it from this ETAP demo features and restrictions. In the licensed version, there we can able to see what are the capabilities the software has. So how many modules we have, how many components we have, those things we can able to get it from this ETAP capabilities. So at this moment, uh, you can able to see the ETAP capabilities are this one. So in the AC inverter, we can able to perform the load flow short circuit through ANSI standard, IEC standard, GO standard, then motor dynamic studies, motor static studies, then arc flash studies, then protection and coordination studies, then power quality, transformer sizing, grounding grid. So most of the capabilities of the all the HITA feature is available in this demo version. But only concern is that we can't go more than 12 number of buses and validity is 1 month. So once the 1 month period is completed, then code will get expired. Then you have to get the new code from the ETAP and you have to enter it, and you can able to continue with that. So anyone have any questions or doubt as of now? No, right?
No doubt, sir.
Yeah, okay, good. ஏய் என்னப்பா ஏன்பா? சரி அப்பா வேலை இருக்கேன்ப்பா, அப்புறமாக்கு வர்றேன்ப்பா, போப்பா. Okay, good. The first one will be the bus. As we know, the bus is the one of the important element in our power system. So theoretically, we studied that we have. Whether my voice is audible properly? Can anyone confirm?
Yes, sir.
Okay, fine. So as we studied theoretically, so we have three type of buses. One is the slack bus or swing bus. Then second one is the generator bus, and third one is the load bus. So here we have to in this ETAP software, at least we need two buses to execute any type of simulation. So the first one is the swing bus and the second one is the load bus. So two bus we need to perform any type of simulation. So you just see in this right side. So in the first vertical, it is the AC component. The first one is the bus element. Then second one will be node. Then bus duct, busway, two winding transformer, three winding transformer, then open delta transformer, voltage regulator, zigzag transformer, scoot transformer, then cable, transmission line, reactor, impedance, then power grid, generator, wind turbine generator, solar PV array, induction motor, synchronous motor, lumped load, MOV, static load, capacitor bank. So some other components also are here. So mostly we will use bus, node, then two winding transformer, three winding transformer, cables, transmission line, then power grid, wind turbine generator, solar array, induction motor, then lumped load and static load and capacitor bank. So these are all the elements normally we will use in our modeling. So other components we will rarely use in our modeling and analysis. That depends on the project. Okay, so for selecting the bus, what we have to do? So we have to just to one click the component and we have to paste it here. You just press and click it. That's all. So you have to just move towards the component. You just press one single press and press inside the screen. So the component will be included in this one. Then so I will try to perform a small simulation and the two bus simulation. Then after that I will explain the concept one by one. So for that I am just taking two buses. So one will be the generator bus and one will be the load bus. So the components what we are deleting, no? So from this edit case, that will come inside the system dumpster. So whenever we want to continue the modeling, so we have to delete the components in the dumpster. So it will, or else the naming it will give the confusion. So I will first I will consider the two buses here. Then I'm taking one power grid, one two winding transformer, then one static load. So in this we have to update the nameplate details first. So, so it means in the last session I told you about the single line diagram. So for doing any power system analysis, what we need the single line diagram. So, so first we need to collect the single line diagram. This one will be our single line diagram for the two bus network. So it consists of one power grid and one power transformer and one static load. So I am just going to model one. I am going to just to give you one small one example about how the load flow analysis for two bus system will works. So for that we need some input components. So I will tell you what all the input data is required for conducting any analysis. So IEEE standard 399 is the best guide for starting any power system analysis. If you are aware about that IEEE standard 399, then it is fine. Suppose if you are not able to, if you are not aware this IEEE standard 399, I will tell you what is that and how it will useful for the power system engineer like us. So IEEE standard 399, it's written in 1997. It is IEEE recommended practice for industrial and commercial power system analysis. So in this analysis, in this standard, it cover almost 18, 16 chapter. Many guidelines are there. So we are doing the load flow analysis. The theoretical information about the load flow analysis is available in this standard. So after this meeting, I am requesting everyone to go to this IEEE standard 399. It is available in this Google itself. You can able to go through this document. So theoretical information about the load flow analysis is there in this document. Not only load flow analysis, load flow short circuit. So most of the power system analysis, the theoretical information available in this standard. So, and in the last session, we seen that the load flow analysis used to identify the equipment loading, bus voltage, real power flow, transformer tap setting, system losses, and some conditions like generator, exciter, or regulator voltage set points. So, some of these are all some of the objective of the load flow analysis. And some important thing is that what all the input data is required, how to perform the data, those things are available in this one. So about in this 6.3 input data, what all the data is required to perform any analysis, then how to consider the base MVA or base KVA for the analysis. You just see here the base KVA of 10 MVA is often used for industrial studies. So most of the industrial power plants will be comes under less than 10 MVA. So they suggesting 10 MVA. So the utility studies we consider normally 100 MVA. But nowadays, mostly we are considering 100 MVA as the base MVA for all the studies. For the bus, so for the bus, what all the input data is required? So bus number, bus name, bus type, that is slag bus, generator bus, or load bus. Then loads connected in that bus. Any shunt element is connected. Then what is the per unit voltage and voltage angle of that particular bus? So these are all the input data is required for the particular bus. So for our case, this will be the bus. So this will be the bus. So for the bus, what are the data we need? So we need the bus number, bus ID. So bus name and number is here. It is ID. So here we have to mention what is the bus name. The generator bus or load bus or capacitor bank bus or a transformer low voltage bus, high voltage bus, that bus name we have to provide. So this one will be our grid bus. So we have to rename the bus. Suppose if there are two grid buses there, means then we have to consider grid bus 1. Then what is the bus voltage? You just consider it is 33 kV. So for the load flow analysis, we need the details of the bus ID and bus voltage, nominal kV. So we need at least these two information to perform the load flow analysis in this ETAP software. Then then second one will be the generator data. What are the data required for the generator? Then third one will be branch data. Then fourth one will be transformer data. So in our simulation we are having the transformer. So for the transformer, what are the things we need? So we need the tap setting and transformer tap angle, then maximum and minimum tap position, then schedule to voltage range with step size, etc. So these are all the minimum input required for perform the analysis. So you just see here in this software. So first we need the transformer ID. So transformer trafo one. So some people will say power transformer one, distribution transformer one, like that. Then about the connection. So primary bus is connected, where this primary bus is connected and where this secondary bus is connected. So we need that information. So so in this one, this bus will be grid bus one. Let's consider the second bus will be load bus load bus 1, and it is considered as a 11 kV voltage. So I just given the name and voltage for both the buses, and about the transformer we have to give the transformer name, then transformer ID. So between what bus this transformer is connected. uh, then go to the rating page. So in the rating page, the once the bus connected bus voltage is updated, so this ETAP software will take this voltage rating automatically. So it is 33 kV and 11 kV. Then after that, transformer, normally we will say transformer power rating. So transformer, normally we will say transformer power rating in kVA, or higher rating power transformer we will consider as MVA. No, so we have to enter the power rating of the transformer. Let's say it is 10 MVA transformer, then we have to enter the rating of the power transformer as 10 MVA. Then next one is the derating of the transformer. So based on the various factors like altitude of the transformer installation, then temperature derating, etc. Temperature rating, etc. Some places we have to derate the transformer. Suppose if we are if we have to use the derated transformer, then we have to consider the derated MVA here, or else if we no need to consider the transformer derating, then it will consider the rated MVA as 10 MVA. So suppose if you are clicking this MVA, then it will change it to KVA unit and MVA unit. So that option is available here. So in this page, we need minimum MV voltage, then MVA rating. Suppose D rating is there, then we have to enter the D rating in this percentage D rating, so that it can able to adjust it. So here some option is available, that is a transformer cooling option, oil filled or dry type, but this will not be considered in the analysis. So this will be just for the information purpose only. Then next one will be transformer impedance. So we have to enter the exact value for the impedance. So the first one will be positive sequence and second one will be zero sequence impedance. So this impedance we need to enter. The first one will be percentage Z, then second one is the X by R ratio. This value we have to enter based on the particular transformer. So this value we can get it from the manufacturer. Suppose if it is ABB transformer, then we have to get this information from the ABB, and we have to refer that particular data sheet. So data sheet means it is the document in which the technical properties or parameters of the particular equipment will be presented in the data sheet. So we have to get the transformer data sheet, and based on that we have to populate this value. So suppose sometimes we may not having the exact value because data sheet may be not available. So that time we can use the typical Z and X by R ratio which ETAP has. So it mostly consider the voltage rating of the transformer and MV of the transformer. Based on that, it will give the values from its library. So by clicking this typical Z and X by R, it will automatically populate these values. So if you have your own values, then you can use it. Then this one will be Z variation. Z means the impedance variation with respect to transformer tap change. So for an example, here it is the first one will be a negative tap and second one will be the positive tap. So for that particular tab, suppose for an example, this 7 percentage impedance with respect to the nominal tab. Let's say the transformer is having in the plus side 5 tab and minus side 5 tab, means the 7 percentage is applicable to the nominal tab, that is 0 tab. So when the transformer position is in negative tab, that is minus 5, that time the impedance of the transformer is different, and that is no longer 7 percentage. Like that, when the transformer is in positive tab, so that time the impedance is no longer 7 percentage, so that time it will be high. So in order to account that transformer tap variation, we can enter the impedance here. For an example, when we are keeping the transformer in the positive tap, so the time the tap will get increase because more number of tap going to add, so the time tap will increase. So that impedance we have to add. Suppose if it is 7.5 percentage impedance, means we have to enter as a 7.5 percentage. Suppose in the negative 5 percentage step, if it is 6.5, means we have to enter this impedance as 6.5. So time being, we can keep this impedance as 7. So it means for varying the transformer tap from nominal position to the minimum and maximum tap, the impedance is remains same. So time being, we can consider that. And the next step will be tap. So in that one we are having two option. One is the fixed tap, that is off circuit tap changer. Then second one is the LTC, that is on load tap changer. So based on the particular transformer what you have, whether it is a off circuit tap changer or on circuit tap changer, so you have to enable the tap changer option is available here. So the first one is primary, then second one is the secondary. It means having the tap changer in primary winding, then the second one will be having the tap changer in the secondary winding. So in some of the renewable power plants, sometimes the tap changer will be in the secondary side of the transformer to control the voltage at the primary side. So sometimes this option we have to use. Then the next one will be the power station. So in thermal power plant and nuclear power plant, the transformer associated with the generator is called as unit transformer. So if it is that transformer, that option is available here. So for that we have to select the particular transformer belongs to which generator. So that option is available here. So time being, I'm not considering any tap changer here. Then next option is grounding. So here we are having the winding configuration as we know. So we are having two type of configuration. One is the star configuration and another one is the delta configuration. So here in primary side delta symbol is there. So it means primary side delta and secondary side star. So it means it is a delta star transformer. So you can able to see the phase shift here. dy 30 minus 30. So the connection type is delta star and it having 30-degree lagging symbol. So please note that why the delta and star configuration is important for the power transformer. As we know, we have two type of winding configuration. So we should know what type of winding is used in primary and secondary. This is important, especially for the load flow analysis and harmonic analysis. Configuration of this transformer is important. And vector group. So about the vector group, so as we know, the vector group it's depends on the particular transformer. Frankly speaking, the we have to select the vector group based on the particular application. So in this one it is dyn 11 vector group. So other options in this transformer page, it's not required for the load flow analysis. Then next one will be the load page. So it is this load is considered as the static load. So for the load, we have to enter the load ID and the connected bus. So since we have connected the load through the single line diagram, so the bus connected bus is automatically updated. So here some option is there, that is what is the load type, whether it is a three phase or single phase, that option is there. And about the type of the load, whether it is a continuous load or intermittent load or spare type of load, that option is there. So and loading, so in the loading we have to enter the power rating in terms of MVA. So I'm just considering 5 MVA at 100 percentage power factor. So normally we will consider the power factor from 0 to 1 or 0 to -1, but here the ETAP will consider the power factor in percentage. So we have to consider in percentage. Suppose if it is power factor is unity, means we have to mention as 100 percentage. Suppose if it is 0.95 means we have to consider as 95 percentage power factor. So like that. So here the power factor is 100 percentage. So 5 MVA here equal to 5 megawatt. Suppose if I am changing this 5 power factor to 90 percentage means, then corresponding real power in megawatt will be automatically updated. So these are all the minimum requirement. So once we done the modeling part, then we can go to this PQ, that is AC load flow analysis. In this AC load flow analysis, we have to first set the case. So here this suitcase symbol is called eddy studied case. So in this one, we have to consider this Study case ID. For a large plant and all, normally we will do various conditions. So one transformer is working, one transformer is out of service, one feeder is out of service. Like that, we will do variety of cases. So for that ID, we have to enter it here. Then second one is the what method we are going to use to solve this load flow problem. So here three option is there: adaptive Newton Raphson, fast decoupled, and normally we will use Newton Raphson method because of higher accuracy. Then what is the maximum iteration? So theoretically, normally we will use the Newton Raphson method or fast decouple method for one or two iterations or three iterations. So when the load flow get converged, so that time we will stop. So that iteration normally here it is entered as 99, but we can go up to maximum of 9999. So up to 49 we can go. Then precision. So precision is the value to check at every iteration again whether the mismatch between the previous iteration and current iteration is acceptable or not. So that part we have to enter. We have to enter it here. So the default is 99 and 0.0001. So that value. So the next one will be the loading page. So the loading, I'm not going to touch it now. I will explain what is loading, what is this generation category in the coming presentation. So once the edit study case information is done, then you can execute the simulation. In the right side bar, the PB symbol is a run load flow. Then second one, auto run on or off, is that to run the load flow. Suppose if you are changing any values means again you have to go and press this PB, this load flow, then only it will start run. For an example, just now I just run the load flow. The load flow has been executed. So just bus voltage only is appearing. So I will just tell you how to see the results and all. Here this Y symbol is a display option. So in this display option, we have some option. So how to visualize the parameters. So bus voltage presently the unit is in percentage. So we have another two more option with voltage in volts and kilovolts. That option is there, and magnitude and phase angle option is there. Then voltage, what voltage we need to see, whether it is line to line or line to neutral. That voltage option is there. Then second one is the power flow, the unit of the power flow, how we want to see, whether it is in MVA or KVA. So on what are the parameters we need to see, megawatt or megavar or megawatt plus megavar or MVA or ampere. So some options are available here. Then voltage drop, what suppose if we are using the cable means what is the voltage drop in the cable. Then branch losses, the real and reactive power losses in the branch. Then second, suppose if you are using ammeter means ammeter and voltmeter means you just display the values of that. So that option is available. So what is the thing? So it is swing bus. Okay. So I forgot to inform that in the power grid option, so we have to model the first bus as a swing bus. So normally we will consider the grid source as swing bus to perform any load flow analysis. So the first one we have to consider as the swing bus. Why? I am just checking the results, but results are not coming. So after converging the load flow, so I'm just getting the voltage only. So not able to get the power flow. So I'm just checking on it. So why power flow is not appearing in this? So, and one thing is that in all the components there is an option for help. Suppose if you have any doubt in this particular page, then you go to the particular page and press the help option. So it will give what is the particular IDs about that information, you can able to get it here. Suppose if you are having doubts in grounding, so in this page if you click this question symbol, then you can get the information about this page. You see, can everyone hear me properly? Whether my voice is audible? Can anyone confirm?
Yes, sir.
Yeah, okay, good, fine. After running the load flow, you will get the power flow like this. I will just show you. So in this single line diagram, can you able to see? Uh, this one is the synchronous motor. This one is the synchronous motor. This motor rating is 150 250 HP. So that motor is drawing almost 61 kilowatt or zero point 0.46 megawatt at 0.242 megawatt. So like that we can able to see the result. So that option is available here. So here now we are seeing the value in megawatt. No, suppose if you are changing in kVA means it will be changed to kilowatt and kVAr. So based on the plant size, we can able to see in the larger plant and all by representing the values in kilowatt or watt will not be a correct one to pronounce, correct one to represent it. So those cases we can go with the higher power rating option in megawatts. Then the next one will be the bus voltage. So this bus is 34.5 kV. This bus voltage, that is grid bus voltage, is 0 degree. So you just see this one will be the load bus. Some loads are connected in this bus. So this bus is nominal kV is 4.16 kV. So this bus is presently operating at 4.17 kV and the bus angle is 0.021 degree. So do you all remember? So when we are solving the load flow, right? So that time the angle will be different. I think you all remember in the Newton Raphson method or fast decouple method. So like that. So here The bus angle is 0. Here it is at 0.021 degree. So this is due to the inductive nature of the system and the winding configuration of this transformer. This transformer winding configuration in the grounding page. So we are following two things, right? The vector group and winding star or delta. So that contributes this winding voltage angle. In in the demo, some capability, some concerns are there with respect to all the equipments. Some equipments may not work perfectly in this demo version, so that only we cannot able to see that one. So just now I just picked up with the induction motor just to see. Earlier I taken one motor and I just deleted it. So that motor is went inside this system dumpster. Here it is available. So that motor named as motor 1, MTR1. So since this motor is in dumpster, so in the same name of MTR1, we cannot able to make any component there. So to avoid that, we have to regularly needs to delete the components in the dumpster. So now I can able to rename this motor value as MTR1. So for the connection of any equipments, so after placing the equipment in this project phase, if you move the cursor closer to the equipment, the bus that location and the pink color light point will come. So that point you can just click it and connect it to the bus. So when I am trying to connect the bus, then the bus also become pink color. So if you leave that leave it, then it will become a connection. So that is one type of connection. Then and also it is easy. Suppose in another one more connection is there. So for that you have to just place the component into this project folder, and you have to open it and you have to select the bus. So in the bus page, what are the buses available in this project? That bus details will be available here. So you have to select which bus you are going to connect this motor. So here it is load bus 1. So I'm just selecting into load bus 1. So it will connect it automatically. So you can do it in two ways. Okay, so about the induction mode, about the motor, you have to give the motor ID, then connection. Then a three phase or single phase. Then next one will be motor. So in the motor, so we have the power rating. It will be in HP. So if you click the same HP, then it will become a kilowatt. So how much is your motor kilowatt? So I am just entering 1200 kilowatt. So then other details, these are all the corresponding kV. FLA means full load current. Then PF means power factor at 100 percentage loading, 75 percentage loading, 50 percentage loading. Similarly, EFF means efficiency. When the motor is operating at 100 percentage load at 92% 0.57 of power factor, that time the motor efficiency is 93 percentage. So these values and all we have to get it from the motor manufacturer. Okay, so other detail, other options in this motor page is not required for the load flow analysis. So once you done the new component, you just go to this PQ page and run the load flow. Oh, okay. This one also is not taking. Okay, I will try here. Okay, so in this, unfortunately, in this demo version example, suppose if we are adding any a new component, so unfortunately we could not able to make the running of the component. So here also this motor is just ideal, but it's not able to draw any power from it. So after this meeting, you just practice yourself that you open this ETAP demo version, and by clicking this new document, you can able to create your own working page. So in this working page, the blank white color screen will be there. So from that, you just pick and place the components into it, and you can start run the simulation for this two bus system. A typical two bus system, the rating of the primary will be 33 kV, and the low voltage bus will be 11 kV. So with that, the transformer option, with the transformer, without considering the tab changer, you just try to run the load flow. So try to keep it in mind that you have to do the all the new addition and deleting of the components from this editing page, and you have to run the load flow by coming to this load flow page and clicking this PB option. So with that, you can able to run the load flow. So how we can identify the whether the load flow is completed or not, so that we can come like this. So in the bus, we can have the voltage and angle. So that one we can enable through this Y symbol, that is a display option. In this display option, what you have to select the bus voltage, how you want, whether it is in kV or percentage or voltage. Then enabling the power flows in units, whether it is in kVA or MVA or VA. Then how you want to see the power, whether it is megawatt or megahour. Whether it is in megawatt or megahour, that one you have to enable. And suppose if you want to see the voltage drop in the line, means you just enable this line or cable. Then suppose if you want to see the branch losses in megawatt and megahour, that you have to enable. And always you have to enable show unit, so that it will show the value, the units also along with the value. Suppose if I am unchecking this show unit, means it will not show any unit near to the result. So here it is just 5.83. So from that we could not able to see what is that particular value. So for that we have to enable always the show unit, so that it can able to give the values and also its units. So you can try to explore the option in this ETAP software, the various components in this ETAP software. So in the coming session, we'll try to fix that issue. So now the new version will in the demo version, the new project phase file will work, but unfortunately it is showing some error. So I will try to resolve this error in the coming session, so that the power flow will work perfectly in this laptop. Okay, so suppose in the meantime when you are trying to do that, suppose if you are encountering any technical difficulties, any challenges, then you just reach out to me in WhatsApp through my private number, so that I can able to clarify the doubt prior to our next session. So here the components list is available. The I will reiterate once again. The first column will be the AC component. In the second column, the first items will be the instrumentation component. The second items will be the DC components. So you try to keep it in mind and try to explore the options available in this software, and also you just to go through the IEEE standard 399, which is available in Google. You just type it IEEE 399. So here one link is available, so this link is getting opening. So in that one, you just to go through the theoretical information about the load flow analysis, and how in this, and this documents will give what is load flow analysis, why we have to do the load flow analysis, when we need to do the load flow analysis, what is the objective, what is the outcome, what are the solution methods are available, what are the input data is available. So those things, the theoretical informations are available here. So the successful or the perfect power system engineer should know the information about the various power system analysis. So when we have to do, how we have to do, etc., and what all the softwares are available presently in the market to perform these analysis. So this document is the best option, best guide to go through that. Yeah, that's all from my side for today's session. If you have any doubts, you please ask me. Okay, fine. If you don't have any doubts, then I will wind up this session. We'll meet in the coming session on Saturday. Coming Saturday 29th, we will meet once again. By that time, I request everyone to go through the software and try to explore the options available in this software, so that you people will get more familiarized on this. Uh, Yeah, about the comments, the message entered in the comment box. Yeah, the recording, we just the recording of this session is available. We will share the recordings with you all. And about the optimization problem, we cannot do the optimization problem by using any algorithm. Some optimization is available in this software that only we can able to do that. So by using any artificial intelligence or optimization techniques like fuzzy logic, neural network, etc., and all, it's not possible to do in this one. Yeah, good. Thank you all. Then see you on Saturday. Thank you. Bye.
Okay, sir. Good night, sir.